While watching this video, please take time to fill out the guided notes on systems of equations. You will need these notes throughout the unit, so make sure that you keep them in a safe location. All right, systems of equations are a set of two or more equations that have the same set of variables. So feel free to pause as you're writing at any time. All right, there are three ways to find solutions to systems of equations. These methods include graphing, substitution, and elimination. Systems of equations can have no solution, one solution, or infinitely many solutions. So we needed a little background information about systems of equations before we can start with doing anything with them. So make sure you pause and fill out your notes. Graphs of systems of equations can look three different ways, really. This first way, you see two parallel lines. And if you have two parallel lines that are graphed, then there is no solution to that set of lines. If you have intersecting lines, there is one solution. Okay? And then when you graph two equations, if they form the same line, then there are infinitely many solutions. And for right now, just make sure you are keeping track and looking at the picture to look to see parallel lines have no solution, intersecting lines have one solution, and infinitely many solutions are caused by one line being the same. Okay? As we move through this unit, we will focus on different types of graphs and we'll be graphing systems of equations, we'll be substituting with systems of equations, and we will also be eliminating to find the solution to systems of equations. So make sure you have good notes about what you'll be looking for. Let's take a look at how solving systems works, okay? So to solve systems of equations graphing, so this is going to tie in directly to lesson 5.1 in Delta Math. So to solve those systems, we start with two equations. Okay, here we have y equals negative 2x, take away 3, and y equals 2x plus 5. And we're going to look at finding the solution to those systems by graphing. So first step is we are going to graph each equation on the same coordinate plane. And if you see this, I've already graphed those. I want you to take a second and look to see which line is which. We should be able to tell that by looking at it. We've worked with linear equations enough that we can tell by looking at them when they're in y equals mx plus b form which line is which. So what do we look at? We're looking to see where that line crosses the y-intercept. So if we look at this first equation, y equals negative 2x minus 3, which one of these lines has the line crossing the y-intercept at negative 3? Right down here. So this one that runs here. Let's double check the slope. So I see the slope is negative 2. That means that it's a negative slope, decreasing, yes, and decreasing down to over 1. Yes, indeed, that line is y equals negative 2x minus 3. So let's look at the next one. If we have the equation y equals 2x plus 5, we should see that that line should cross the y-intercept at 5. Found that. Looks like this one right here does. It is positive, so should be an increasing upward slope. And what is the slope? It is 2, so it means you're going to rise 2, run 1. So look at any point, rise 2, run 1. It does look like it fits. So as we reveal that one, so this line right here is in the y equals 2x plus 5. So when we see lines graphed, we can find the intersection point in the solution to the systems of equation. So the graph intersects. Where's this graph intersect? The point in which the two lines meet up. Okay? Yeah, double check. You're right. It's at negative 2, 1 because it went back 2 from the origin, up 1. Good. So the graph intersects at -2, 1. So to check this estimate, we do that by replacing x with the x value of -2 and the y value of 1. Give me a second to catch up with those notes. Remember, we can pause at any time. All right, and then we want to check our estimate. And we can check those by substituting x in for x in our equation, y in for y, and when we do the calculations, we see that the left side of the equation equals 1, the right side equals 1. And that's the case for both equations if we use the coordinate -2, 1. It's where they intersect. So then we can say that the solution to the system is -2, 1. So that is the solution to the system. Let's move on to looking at an example from 5.1, day 1. Okay, this is number 1. So we want to solve the following systems of equations graphically on the coordinate plane. All right, so the first thing, we're just given 2 equations. What do we need to do? We need to graph each of those. So let's start by graphing y equals x plus 2. First thing I need to double check, is that equation in y equals mx plus b? It is, because if it's not, graphing is, you need to wait and rearrange it to get it in y equals mx plus b form. Okay, y equals x plus 2. All right, so I see my y-intercept is positive 2, so I'm going to drop a point there. And then my slope is in front of x. It's not there, so what is it? I know it's positive. So what number should be there? Oh, that's right, I can slip a 1 in there. So it could be a slope of 1. So that means I am going to plot some points around my y-intercept. So I'm going to jump up 1 over 1, up 1 over 1. I highly suggest you plot points on both sides of the y-intercept to help with connecting the dots to form the line. So I need to go backwards, so that means I could go down 1 and back 1 to keep with that positive slope. Now that I have 4 points plotted, I can connect the dots and have a good line. Now that we have the first line graphed, we can work on our next equation. Y equals -1/2 x plus 8. Hopefully you're thinking to yourself, okay, that means that there is a negative slope, as thinking about which direction that graph's going to go with a negative slope. Right? I find my y-intercept, it's positive 8, so that's my starting spot. I start with my y-intercept. Then I focus on my slope. My slope is -1/2, so that means I'm going to go down 1 over 2. Plot another point. Down 1 over 2. Plot another point. Oh, notice I just figured out where those lines intersected. I could plot 1 on the other side of the y-axis by going up 1 and backwards 2 to fall in line. So now that I have 4 dots, I can connect my dots and form a line. Now that I have my lines both drawn, I can find the spot in which they intersect to see if they have a solution. I know that the intersecting lines have one solution, and that one solution is where they intersect. So we identify that coordinate. So over 4, up 6. So the solution to these 2 equations is 4, 6. All right. You have several more examples in Delta Math Lesson 5.1, Day 1. Remember, you can always watch additional videos to see more examples. If you need help, message me. All right. Oh, one additional detail that I almost forgot is that I almost always, when I am plotting lines and I'm doing this by hand, I also label my equations. So I label my lines with my equations so that I don't get confused. So label those so that you don't forget which line is which later.